Thank you very much. Thank you for coming to my session. I'll be talking about networking, basically. So this conference has been aimed historically at vulnerabilities, malware, code disassembly, and so on. And I'll be talking about something different, which I think it is also quite a good area of discussion. And if I could ask you, to the gentleman in the row in the back, not to point the laser at my forehead, I would be grateful, thanks. And so what I will be talking about today is the approach we can take today to embrace the identity networking and extend it to the whole network, no matter if it is the enterprise, if it is the campus, if it is the WAN, if it is the wireless. And this is something totally different than we had in the last, let's say, 10 years, and I hope you will like it. So the first assumption I will be making that you have some familiarity with identity-based networking. The topic I designed for my session is a little bit complex, but it reflects what is going on currently in the networking security, in the core networking security. I mean, in the switching, routing, in the overlay models. And I will be discussing various use cases and technology behind it to actually achieve it. And what we would like to achieve, I will explain you in a moment. So holistic means that we want to extend the concept I will be talking about today to all the types of the networks. And when you are doing something, you are for sure connected to the network. So we take the network for granted, but there are some places in the network, and there are some specific networks like the company networks, and the companies have the right to protect their infrastructure and to impose the security policy upon their users. It is a little bit different than we have in the internet. The network is controlled and has to be controlled. The network administrator and security administrator needs to have the capability to reflect the security policy into the infrastructure itself and how to do it. So I will be talking about the most fundamental thing, how to put the user or his machine into the network and make the network aware of this machine. It is a very interesting topic. I think that it's not so easy to actually invent a model which would allow us to do it. And the last thing is, of course, the dichotomy, the clear division between the imperfect world and the perfect idea, right? The perfection is embraced only in other, let's say, sciences, and telecommunications, and specifically the network security and security as a whole, is not perfect, right? Bruce Schneier once said that if you think that technology will solve your security problems, you don't understand the problems and don't understand the security, okay? So this is not about perfection. And let's go. So the first thing I would like to ask you, and raise your hand, if you have successfully deployed actually .1x in your networks. I mean, not the wireless LAN, which is pretty ubiquitous, but if you could raise your hand if you had success in implementing end-to-end .1x, which is a, let's say, year 2001 or 2 standard, so it's 10 years old, who had success, or runs the whole network in your university, I mean, at your home, or at your company. I don't see many hands up, so I think a valid point is that we need to talk about it. And I will show you what has happened since the last 10 years to allow us to actually do it and to implement it and to create the, let's say, the context awareness. Context awareness is a marketing buzzword, but it is perfectly reflected in the technology. And this is what I would like to expose to you deep in depth. So this is the problem statement. The technology did not fail, but it did not provide certain features and behaviors and flexibility to actually implement it. And this is quite funny because what happens in the authentication scheme when the device connects into the network, if you are using a classical .1x, it should get authenticated, and before it gets authenticated, it does not have any network access. This is the classical IEEE .1x. And the problem with that is that it is not very feasible to do it, because the endpoint, when it gets to the network, it needs to get some DHCP IP address. It needs to be able to reach the DNS server and other fancy things around. So a couple of network services need to be provided in order for the endpoint actually to function, no matter if it is a wireless or wired network. And the standard says that you cannot do it because the switch port will drop all the frames except for IP over LAN frames, no matter what IP method you are actually using. So it's not that flexible. And we needed functionalities on the infrastructure, the switches, wireless controllers, if you are talking about the centralized wireless model, to actually do the incremental implementation from the open mode to the low impact mode to the high security mode, where actually the administrator can implement these features in phases, not to cut off 1,000 users from the network at day one at 8 a.m. This is the problem. It leads to catastrophic condition, and for the network administrator and security administrator, it's normally an RGE, which is a resume generating event. The moment in your career when you need to update your CV, because now you will be sending it to the market. Not a very good idea at 8 a.m. on Monday morning. What more happens? Some endpoints are and will not ever be .1x compliant. They will not be able to authenticate and use .1x because they don't have supplicant. These are unmanaged IP endpoints, and we need to manage it. And we need to provide the flexibility to authenticate using MEBs, MAC authentication bypass, or other mechanisms like web authentication, where the user has something wrong with his supplicant, and he connects to the network, and he gets redirected to the web page because the .1x phase did not work. And we need all these three phases implementation capability on the switch, and perhaps in the wireless network as well. So the problem is the system level approach, where you have the infrastructure, which consists of the endpoint, which is normally a desktop thing, an operating system with a supplicant, and there are many supplicants. You have a switch, you have an authentication server. Many different points which need to interoperate smoothly, and actually for the last 10 years, honestly, they did not. If you look at the native, for example, supplicants in the most popular, maybe not in this room, but anyway in the industry, on the endpoints in the enterprises, the Windows system, the .1x supplicant was not fixed until Windows XP Service Pack 3, because it operated a little bit indeterministically, basically. So this is the problem. I'm also taking IP telephony into consideration. So you have two endpoints and at one switch port, because you have a phone, and behind the phone you have a PC connected to it. Okay, so you need to authenticate these endpoints on one physical port, but in two logical domains, and you can have more than two logical domains if you construct a network like this. So I will give you an example of how do we do networking segmentation in the most ubiquitous guest access. You need to separate the traffic. Guest means a person who connects to the network in your company and gets breached or routed to the edge firewall, and his traffic does not touch an internal network at all. It does not touch internal network if you separate. If you separate by VLANs, I think that not many of you are implementing MPLS in the campus, but some organizations do. But it's a little bit hard. And the last thing you need to provide is to provide a separation at layer 3, which is a VRF. And yeah, that's it. That's a very simple thing to do, but not so easy from the networking point of view. If you have a huge network, many branches, and you need to connect, you need to connect guests to it in a feasible and manageable fashion. And the next thing is that authenticating is not enough. I mean, you need to differentiate the endpoints. And how can you differentiate? You can differentiate using many different attributes. And these attributes can be a user identity itself, if it is a valid user, because you are connecting the authentication system to your directory service, no matter what it is, what kind of device it is. Let me ask you a question. How do you know what device connects to your network? Do you know it? How do you check it today? It's a very complex task, and I will show you how to approach this. It is not perfect. We can have an academic discussion on that, but there are some ways invented to actually say that this endpoint is an iPad with iPad 2, let's say, or an Android device, or a Windows machine, or Ubuntu Linux, for example. The next thing would be a place. To which switch geographically, in which branch does this device connect? You have to ask if you need to provide the same access to all of these devices connected to many different places in your network, wired or wireless, or perhaps VPN, right? The next thing would be a posture. And this is where NAC comes into place, the network admission control or network access control, where you have to understand if this endpoint is compliant, if it has the antivirus installed, the proper registry keys, the files on the system or files which do not exist on the system, proper services launched, and some processes running. And then you can grant access into the network. And if you don't, you need to quarantine the endpoint and give the user the ability to click through all the service packs and hotfixes and antivirus signatures he needs to install. And you need to guide the user, because not all the users are these technical savvy, so they know everything about technology. They just want to click and go through it and have the full access to the network, right? And do their job and go home. And the time, obviously. Do you want to differentiate 8 a.m. and 11 p.m.? Maybe something's wrong when a machine accesses your network at 11 p.m. or 2 a.m. in the morning, and you need to think of it. And access method, what kind of access? Wired, wireless, VPN, and other attributes like certificate attributes if you are talking about certificate authentication and so on. And this set of attributes creates a kind of context, which enables us to differentiate the access to the network for the users, okay? And the last column here is the permission. And what is the permission? It can be many different things. It can be an access list applied to the port dynamically, or a VLAN, or even some other mechanisms which I will discuss in a couple of slides, right? So now I would like to go a little bit into classification. And classification means profiling. Profiling is a special term coined to put an umbrella on all the technologies which would enable you actually to give the answer to the question, what kind of endpoint connects to your network? It's a hard task. You can do whatever you like with your endpoint, and if you can spoof your MAC address, your HTTP user agent, create fancy traffic, and so on and so on. So if you are doing it, then probably, or if an attacker does it, then probably you need to think of it as well, because it is not perfect, but it is a very good approximation of what comes into your network, right? So what you can actually do, you can use many different things, and it is called probes, to get the information from the endpoint, push it to the authentication server, centralized point, and evaluate it and apply a profile to this specific endpoint based on what it actually is. And there are many different things that you can actually check today. And you can ask yourself if it is a valid approach. I think that we need to do it today. It is perhaps not perfect, but if the attacker is able to, to root your device, totally spoof Mac OUI and create a false user agent, play with DHCP attributes he's sending, I think in your network you have an issue of other kind, not of this one, right? It's a major threat. So what you could do today, and this is actually a screenshot of a live system which is actually productized today, right? Of course, many different vendors do it in a different way, but at least you should provide this. And these are 8 methods, and there is also a 9th method, which is a HTTP span, which is not that convenient because you need to span the traffic from the access switch to the profiler. And profiler is a software running somewhere. It can run as a software module on authentication on a Radius server, which does the authentication and authorization as well. And spanning HTTP traffic from hundreds of endpoints is not very, actually it's not very flexible, but you can do it. And you can get this additional information which I showed you on the previous slide. At the bottom there was HTTP user agent, right? Safari or Mozilla on an Apple platform. And you can provide additional vector of profiling into it. So what happens is that if it is not feasible to centralize, you can put the profiling into the network devices as well. You should think of it. Do I want to centralize if I have 10,000 users, or put some logic on a switch or wireless controller to actually do the profiling on box and send the result to the authentication server, just for the authentication server to provide a Radius response and give the differentiated access and change the VLAN or an ACL to the switchboard, right? So this is an approach which can be taken on the switchboard, and here we have 2 probes running on an access switch to which a user is connected, and actually it is a IP phone, right? So we have a CDP probe and we have a DHCP probe, and by doing DHCP snooping and by grabbing the CDP messages, and CDP or LDP is normally used in the IP telephony networks because it is used to provide power, and it is also used to provide voice VLAN, right? So you are normally running CDP and LDP. I am not talking about security of these protocols. They are basically not secure because there is no authentication or encryption. But I will show you later how to provide layer 2 encryption for the full context awareness. So if you look at such a system, you should at least think that, and you should expect that it provides profiles out of the box to take the profile, and when such an endpoint arrives in your network, it gets profiled. Of course, you can control it. You can create your own profiles. You can copy and manage these profiles, and you can actually dig into the profile and change the decision behavior, because it is not magic. It is a decision process. It is an algorithm which tells you that this is, for example, a Sony PlayStation 3 connecting to your network, which gives, of course, let's say, productivity boost for some people and diminishes productivity for others, especially if we are talking about the enterprise environment, right? I discussed a little bit the ingress control, where you apply ACL to the port or you apply VLAN. But with ACLs, the funny thing is that switches are hardware platforms. And if you want to create a really big ACL at the ingress port, normally the access switches are a kind of low-end switches. Nobody puts a big modular, or almost nobody, right? Puts a big modular switch with lots of TCAM hardware resources to actually process the ACLs. So at some point, you run into the TCAM limit of a platform, and then it starts to perform in software, which is really, really bad for the performance of the whole box, because the central CPU on such switches is a very, small one, and you cannot run it like that. So what we could do is to approach it from a different way. We take the context, all the attributes of the user, and we provide differentiated access, and we filter at the egress, not at the ingress of a network. And we would like to do it flexibly and extend the knowledge that this exact device comes into the network to the whole network. Okay, so every single device, not only the access switch, knows that this user or this device comes to the network. And how to do it? The answer would be to propagate the context in the network. And if I want to propagate the context, I have basically two options. One would be data plane, to put some little tagging into the frames, or put some overlay mechanism to communicate the devices between themselves. But the assumption is that suddenly you need to make your devices somehow context aware, which means additional logic, software or hardware capabilities, if we are talking about hardware tagging, which I'm mentioning, right? So this is the question. And let's discuss a little bit what is happening in the standardization space. IEEE has standardized a couple of years ago, 2006, the IEEE .1AE, which is a MACsec standard. And MACsec is a layer 2 encryption mechanism which allows you to encrypt hop by hop. It's not IPsec layer 3 end-to-end, or SSL VPN. It's hop by hop. So if you connect two switches, one of them encrypts at the port level, and the second decrypts at the port level, so that the traffic comes unencrypted into the port logic. So you can do anything with the traffic, like you can do NetFlow, you can do access list, you can do some traffic analysis, you can do quality of service. And this is what you like to do really in your campus network, if you are serious about transporting voice or video and providing differentiated treatment for the traffic. Because if you don't, then you buy a $50 switch and it works as well. Although you can run 20 most popular layer 2 attacks in a matter of minute. And in my second session, I will be discussing the IPv6 layer 2 security, because IPv4 is something that we have been dealing with for a long time. Okay, so. What is the idea? The idea would be to encrypt all the traffic and to use the MACsec frame format to actually transport the context. And think of it, if you are not encrypting the traffic end-to-end in your network, you can run into trouble. And the trouble means being prone to man-in-the-middle physical attacks. And these attacks have been demonstrated. You can run them, a small factor PC, which is a kind of a soapbox size. You can put it in the floor box. And if a user comes and opens the floor box and he sees, what's this? You can answer him, okay, it's a signal enhancer. Okay? So that's the problem with, if you are not encrypting and authenticating, then a problem arrives, right? So what you can do is you can encrypt the traffic from the user to the switch and switch to switch as well. And this is done in hardware, so this is very effective. It is a crypto chip on every single port of the device, so it is basically doing everything wire speed on the platforms which actually, of course, support the MACsec standard. You can do also massively massively scalable interconnection if you are running layer 2 between your data centers. Think of 80 gigabits per second encrypted link done in hardware by the switch platform. You don't need to add any encryption device between. And it is something that is supported today. Actually, for the last couple of years, it has been supported. Okay? So what we are doing in terms of context, we are taking the MACsec frame, and here, because the MACsec frame provides us capability to put a certain metadata inside, we are utilizing this metadata field, and we are putting the context. And the context, let's say, in the first approach, could be just a number. And let's call it a context number or a secure group. And SGT stands for secure group tagging. Okay, so you are putting a tag, like in .1q trunk, and you are coloring the frame with a tag which reflects the context of a user who comes into the network. And by doing that, suddenly you are able to propagate the context hop by hop in your whole network. Of course, you need to have devices which are supporting this standard. But more or less all the devices, the switching platforms today support these when it comes to Cisco platforms. And how do we put a tag inside? So a tag is being applied by the authentication server during the .1x authentication phase. Okay, so sorry for that. Here, when you are doing show authentication sessions on an interface, you can see that user employee 1 has successfully authenticated and authorized on, against this port. And what has been applied? The access list has been applied, IP employee ACL, which is a normal ingress access list. But the second thing, what happened here, is a tag has been applied. And this tag will be propagated in the whole network end to end. And all the devices which can make use of this tag will use it for additional filtering, enforcement, and segmentation behavior, or firewalling, for example, and I will show you a use case for that. Okay? So the classic example would be a kind of campus environment where you have a users coming from the top into your network, and the bottom is the data center. Normally, the users connect to some servers and do some work, right? So here are the servers, here are the users, and when the user authenticates, he starts to send traffic. And the traffic he sends is being directed to certain hosts, to certain servers. And the funny thing is that you can do, when the traffic enters the hardware-capable domain, let's assume for the sake of demonstration that all of these switches are able to tag with SGT, the traffic gets propagated until here at the very egress of your network, it is being filtered very effectively in hardware. And why it is effective? Because you are getting totally rid of complex access lists, because the access list, which are called the SGACLs, the secure group ACLs, are not taking into consideration the IP addresses, because we don't care about IP addresses anymore, because the user is reflected into the certain group. And in a normal enterprise, you can group all your resources into several dozen or let's say 100 of groups. You don't need to create one group for every user. You don't normally do this, right? So it creates a huge simplification. So this is the access list, which as you can see contains no IP addresses, none. And the second thing that you build centrally for the whole network, which is also a huge benefit, is creating this matrix which says that user A, which belongs to group number 10, cannot access the server C, which belongs to group number 333, okay? And you create this matrix once for your whole network. For your whole network, no matter if it's a WAN, campus, and so on, or wireless LAN. And this matrix is being fed into all devices which are context capable, And the security administrator administers this list from a central point, only in the network. You don't need to create 100 ACLs on every individual switch in your network, which is a pain to maintain and to replicate. So how it works, you are binding the user to a specific group, right? And then you reflect a specific traffic directions. So the traffic patterns which are allowed by your security policy or are not allowed in your network. And then you are doing proper filtering at the egress, because as I said before, the problem we are running into with ingress filtering ACLs is the scalability normally. So this is a very good idea, I like it, but 90% of my devices are not MACsec capable, and I don't want to bring a truck with new routers, switches and firewalls, throw everything away and put new devices inside. So what I could do is I could invent a lightweight protocol to transport the context information between devices. And let's call this protocol a SGT exchange protocol. So what happens here is the access switch, which is not MACsec capable and has not the capability of tagging at the ingress, what it does, it takes this information, takes the binding, and transmits the binding to the nearest MACsec and SGT capable switch, which would be called a seed device. And how do you do it? This is a one use case scenario where you have a user connected to your branch number 120. Here you have a router has a switch, you connect to it, you do .1x, and by doing that, you are providing a context to the user, okay? And the context is being bound to the IP address of the user, or IPv6 address of the user, okay? And what happens is that this router connects with SXP to the nearest hardware-capable device. And when the traffic, which is here, a normal traffic, untagged traffic, reaches the first device which can actually encrypt and tag the traffic, it is being tagged. Normally it would be a data center where you have a big fat switches and they can do almost everything, right? And you are doing enforcement. What more can you do? Because I was talking about ACLs. You know that ACLs are stateless, right? You are just filtering based on the regular expression. But we need to provide more security services like firewalling, IPS, load balancing, and so on and so on. And you can also do, and this is an example of a router with an integrated security feature which is called zone-based firewall. And you are firewalling based on the tag. It doesn't matter that this tag is only a logical construct. It is not in hardware, because this router cannot tag in hardware. But it is not a problem. The binding table is being built. And this is good. And you can do it at the ingress, at the egress of the network as well. So with more services, let's assume that we have a firewall in the data center. And we want to provide a secure group firewalling right now. And what can we do? We can put a firewall for segmentation and traffic filtering in front of the data center. It is not a problem today to have 40 or 100, even 100 gig firewalling capability for V4 and V6. You can do it today. I mean the real production traffic volume, not the datasheet marketing traffic volume, right? Okay, and this firewall will filter based on the tags. And this is how it would look like if you are using a graphical user interface. I know all of you like the CLI, but if you have an access list of 1 million entries, and this is normally what you have in the data center, and the companies I'm working with have this amount of ACLs, you start to think about the GUI, because in CLI, I mean, it is not that feasible to actually look at it even. So here, what happens in the firewall rules, you are putting additional column, which is a security group, a source security group for the user, for the traffic, for the source of the traffic, and the destination security group, which is for the resource which the user is actually trying to access, right? Another use case would be more and more popular VDI scenario, where the users are connecting with the thin clients to the remote desktop through a broker. And what happens here is the user connects to a virtual desktop in the data center. This virtual desktop gets .1x authenticated, and the same like a physical user, this virtual machine also gets a proper context-aware tag, right? So it gets its SGT tag, which can be propagated in the network, and normally this VM will access some servers in the data center. This is normally how the users work. They don't exchange too much information between themselves, but if you want to do it, you can do it as well. And the last thing I would like to share with you is the BYO story, which is a industry megatrend. Bring your own device, PC, laptop, smartphone, whatever. And it creates an immense pain on security and network administrators. And if you are doing something in an enterprise, managing network or managing security, you are thinking how to do it. Do I want to get 100 calls from my users a day because they just brought a new iPad? And normally the users who bring their iPads are the users who make decisions in the company, and they want to make things work. Sorry, but this is the reality, right? Or fantastic, this is the reality, whatever turns you on. And what you would like to achieve, you would like to give the user the empowerment actually to provision his device, to connect to the network, to apply a proper wireless SSID and encryption, so download a profile, download a VPN client if you want to connect to the resources, and also you would like to profile this user, so classify that this is really an iPad. And also you would like to provide the user with the capability to take your favorite MDM solution, which is a mobile device management, right? And if your company policy says Angry Birds are not allowed, you need to execute on this, right? So the MDM solution would need to be able to feed the information to the authentication server to actually force the user, when authenticating, to posture his device and evaluate if there is an Angry Bird on his smartphone. And if there is, he gets a differentiated access. For example, he has access to the internet, but not to the corporate network. And what happens? He can, for example, he can remove Angry Birds, or he can do whatever he likes, but until he does it, he's not able to access. He's in a quarantine, let's say, or in a guest access, he's breached to the internet. So this is the general idea, and you want to combine the authentication by certificate, the user identity group, the MDM, the profile of his device, all of this, and you want to empower the user to actually add the devices. If he has 5 iPhones, no problem, I will add a new device because I provision every single device using a simple web page so everybody can understand, and it's localized. So if you're in Poland, for example, some users like to speak in Polish. Basically, even let's say the regulations enforce that it's in Polish, right? So these are the kinds of questions you are hitting every day in your in real life, right? And that's it. So bring your own device is a trend which we need to somehow embrace. And what I would like to point is that technology is mature enough actually to do it. And at the very beginning, I have asked you, and nobody raised hand, if you are running .1x in your wired network, right? And this is why also this session happens here, to share with you the brave and good new message that you can actually do it and it works. You can do it today, not only for wireless. And the the secure group tagging and the context awareness is an end-to-end concept, which is also a new direction in the IBNS story, and valid to point, I think, also valid to evaluate. It provides very nice and decent features and also use cases, and also simplification of many things in your network. So I'm leaving you with a little bit of thoughts about it. If you want to look how it's implemented, specifically a vendor implementation, which means a Cisco implementation, by the way, you can go here, or please reach us out at our booth. We'll be happy to discuss with you, because there is many technology things that I did not have even time to mention by one word to actually look in depth how it works. So thank you very much. I hope you enjoyed it and enjoy the rest of the conference. Thank you very much.